For problems 1 and also 2, we're just going to add all the values and of course divide by the number of data points. I did that here. I got 56 and number of data points is 8. 56 divided by 8 is 7 and the mean is 7. For number 2, just add them all up. You'll get 54.8. There are 10 data units, so I just went ahead and divided by 10 to get 5.48 there. For number 3, here we have the data points. I counted n as 9. I rearranged them in order from least to greatest. And then since there's 9, the one in the middle, which would be the 5th one right here, so we have 4 values on either side, that is the median. It's good that this is an odd number because in the next example, number 4, we actually have n is equal to 10. So again, I arranged the data points in order, but this time, since there's 10, we have 2 data points that are sort of in the middle. What you do there is just take their average, the same way you did it up here, just add them together and divide by 2, and you get your median that way. So they're the first 4 problems. For problems 5 and 6, all we need to do is find the data item that shows up the most. In 5, you can see 2 is the one that shows up the most, so it's the mode. And for 6, if you look through there, 1.4 shows up the most, so it is the mode. So all you do is count the one that shows up the most. Here we have number 7 is asking for the range of the group of data. So we have the highest minus the lowest. In number 7, 15 is the highest, 11 is the lowest, so the subtraction is 4. And in 8, 19 is the highest, 5 is the lowest. The difference is 14. Okay, for problem 9, we're going to find the standard deviation. First step is to find the mean, also called x with a bar on top of it. So for problem 9, I took the data points. There's n equals to 5, adds up to 50 divided by 5, which is 10. Of course, I think you can see the mean was 10 anyways on this one. Step 2 is to take the data point and subtract the mean. So I did that. Each data point, 8 through 12, subtract the mean, and you get these numbers, minus 2, minus 1, 0, 1, 2. Note that those things add up to 0. These are called the residuals. And then what you want to do is square each one of those numbers. Minus 2 squared is 4, minus 1 squared is 1, and so on. And then add those numbers up to get to this number right here, which is 10. Step 3 is we're going to take that number and divide by 1 less than the number of data points. So n is 5, so we'll be dividing by 4. Reduces down to 5 over 2, which is 2.5, and this is called the variance. And then step 4 is we're going to take the square root of the variance to get the standard deviation. Just put that in your calculator, you get 1.5811. We'll just round the standard deviation to 1.58. For problem 10, we're going to find the standard deviation one more time. So here I found x bar, or the mean, where n equals to 8. Add them all up, divided by 8. You get 116 over 8, or 14.5. So the mean is 14.5. Next step is we're going to go ahead and find x minus x bar, find what they call the residuals. I did that here, noticing that each time the answer comes up to be either 3.5 or negative 3.5. And then so noting that 3.5 squared, whether it's negative or positive, comes about to be 12.25. And there's 8 of those, so those add up to be 98 altogether. Notice that the sum of the residuals is 0. Sorry for the bad handwriting, but it is 3.5 or negative 3.5 for all of them. Then what we do is we want to take this 98 number here and divide by 1 less than n. n is 8, so we make 8 minus 1, which is 7. That turns out to be 14. That's the variance, but we want the standard deviation, which is the square root of that number, and it's 3.7416, and we'll just round it to 3.74. The answer guide did something like this. This is what they have. Notice it's the same thing. I would be very fine with 3.74 as your answer. For problem number 11 and 12, actually, we're going to use this empirical rule. This is for the normal distribution. It's also known as the 68, 95, 99.7 rule. I've drawn it here with some of the percentage points. You could look this up in My Math Lab in the text, or just look it up on the internet and you can see this picture. And question 11 says, what percentage of the data points fall within one standard deviation? On either side of the mean, you get 34%, total of 68%. That's actually part of the name of it. So 68% fall within one standard deviation. Problem 12, we were talking about 3 standard deviations. That's up here. It says if an adult male is told that his height is 3 standard deviations above the mean of the normal distribution of heights of adult males, what can he assume? Well, he can assume that he is taller than about 99.7% of all the other people that were measured in their heights here. In other words, he's really tall. He falls into the 99.7 percentile. So I'll say, well, we could just answer that. Take a look at the answer guide, and it says taller than 99.7% of all the other males that were measured. Okay. For problem 13, we are given that the mean is 100, the standard deviation is 26, and the question is find the score that is 3 standard deviations above the mean. So looking at this picture, Ms. Miller, I drew another representation. I have 1, 2, 3 standard deviations. You just add 26 each time to get to 178. So that's 100 plus 26 is 126, plus 26 is 152, and plus 26 is 178. So you just add 26 each time. You could actually do 100 plus 3 times 26, and that turns out to be 178. It's kind of better sometimes to draw a picture though. So the answer is 178. For problem 14, we're given that the mean is 150,000 and the standard deviation is 900. So if you add 900, you end up 1 standard deviation above, and if you subtract 900 at 149, 100, you're 1 standard deviation below. And the question asks, what is the percentage of buyers who paid between here? So it would be, well, 68% using the empirical rule between 1 standard deviation above or below the mean. Okay, for problem 15, we are still working with 150,000 in the mean. This time the standard deviation is 2,500. And if you add 2,500 once, you get 152.5, and then twice you get 155, and 3 times you end up at 157.5. The question asks, what is the percentage of buyers who paid between the mean and this number right here? That's 3 standard deviations above the mean. So that's these 3 percentages added together, or since we know this is symmetric, you can take the number 99.7, and just cut it in half, and you get 49.85. Okay, so that's the percentage right there, 49.85. You could also add these 3 percentages, but I think it makes more sense to see that since it's symmetric, it's going to be this half of a number we already know. So half of that number right there is a quick way to do it. For problem 16, we are still working with the $150,000 mean. This time the standard deviation is 2,200. And if you go down 2,200, you get 147,800. And go down another 2,200, you get 145,600. And that's the question. Although notice it says less than this. So we're looking for this value right here. Okay, to do that, what we're going to do here is we're going to take a look at this value, I believe here. This is 50% from here to here. This is 34% here. Then we have 13.5 in here. So if we add those up, we get 50 plus 34 plus 13.5, and we end up with 97.5. So 97.5% will be above, and since this has to cover all of it, we can subtract 100% minus that number to get 100% minus that is equal to 2.5%. we could have done this just noticing that this is 50% here, and 50 minus 34 minus 13.5 is also 2.5%. Okay. For problems 17, 18, and 19, we are going to use the z-score formula here, which is the data point minus the mean, all of it divided by the standard deviation. X minus the mean over the standard deviation. For all three problems, the mean is given as 60. That's represented in the question. The standard deviation changes for each, and of course the data point changes for each. But for 17, it's 70 minus 60, which is 10 over 10, which is 1. And then you can see the calculations here. 78 minus 60 is 18, divided by the standard deviation of 12. You get 3 halves, or 1.5. And number 19, notice we have 55 minus 60 is negative 5, divided by 5 is negative 1. For problem 21, we are going to use the table that's at the end of this review. They give us a z-score of 0.3. If you look on the table, 0.3 has a value of 61.79%. That means all of the area up to that z-score of 0.3 onto the left of it. The whole thing has to add up to be 100, so 100% minus that is 38.21. Therefore, 38.21 is on this side, 61.79 is on that side. And it says A, what is the percentage that lies above? Well, that would be the 38.21, that's above. And below is actually what the z-score gives, below 61.79% for number 21. For problem 22, we're given a z-score of 1 and a z-score of 2. On the table, again, at the end of the review, you look up the scores for z1 and you get 84.13%. For z equals 2, you get 97.72. It's on the table. Now, what we want is the percentage in between there. So what I'll do is take all of this up to 2, 97.72, and subtract all of it up to 1, which is 84.13. We do that, we get 13.59%. Now, it said to round to the nearest whole percent, so rounding that, because that's a 5, this goes up to 14%. Problem 23 is just like problem 22. Negative 0.02 on the table makes 42.07. Remember, that's the table at the end of the review. And 0.2 gives a value of 57.93. Again, from the table, those are percentages. So we're going to go all the way to 0.2 and then subtract all the way to negative 0.2 to get this value minus this value, which is 15.86. Don't forget it's a percent. And they did not say to round this time, so that's the exact answer right there. For problem 24, we're given that the mean is 500, the standard deviation is 100, and we're interested in the score of 650. Okay, so what we're going to do is take the data point 650 minus the mean, divide by 100, which becomes 150 divided by 100, or 1.5. Go to the table, z equals 1.5 gives 93.32, that is everything below. And that's what they're asking. So what's below the score of 650 is 93.32%.